Yo, what's up guys, it is Blade Danger here back with another video, and I'm gonna make another video describing why the Earth definitely has to be a sphere, and why it cannot at all be flat. Here we go. Just keep an open mind. Please watch. So, if the Earth was flat, and you were standing on it looking out into the so-called horizon, it would form a right triangle, which means that your eyes, especially if you're looking at the ocean, because because liquids fill their containers. Everyone knows that. Liquids take the shape of their containers. That means if the Earth was flat, the ocean would be flat, which means if you were standing at a beach looking out into the ocean, you would be able to see, if not Europe, at least the mountains of Europe. But guess what? You can't. The only kinds of things that have horizons are things that are round. And it's simply because if it isn't round, it's not going to have a horizon with anything over it. You're going to be able to see everything to the very end point. So the only way the Earth could have a horizon is if it was round, at least somewhat. Okay, so we know that it has to be at least a semi-sphere, at least. But the thing is, on a globe, even in the flat Earth like model or map of the Earth, all the oceans connect. And because ocean or liquids in general take the shape of their containers, it has to be a sphere. There's no arguing it. There is no other explanation. It's a sphere. I had pictures that I took. Like, you can't see Europe's mountains, mate. And if it's even somewhat round the ocean or anything, then you know that the whole planet's gonna be round because all the oceans connect with each other. This, combined with everything else that I've made, you can't argue it anymore. And more proof that it is round is when you go higher up on the Earth, you can see further over the horizon. With a flat Earth, you would see everything on a higher angle. So technically, like, you could see over smaller buildings. It would appear that you could see more. But something for, like, if you're at the ocean looking at Europe, if it was a flat Earth, you wouldn't. It doesn't matter how high up you would go. You should still always be able to see Europe. But obviously you can't, even when you are up really high. So it's 100% debunked. The Earth has to be 110% round, or else it completely defies the laws of physics. There's just nothing else to it. Everything else in the solar system we have observed, including the moon, that has lunar phases, therefore, it has round shadows, therefore making it has to be a sphere, according to my model, and everyone else's model, and just common sense. And obviously the Earth follows the same thing, the fact that it's daytime here and nighttime, like in Europe, while it's daytime here, and then the other way around. And there's also time zones in both parts of the world, and the fact that the oceans have to be completely round, and then the ground is always, I can't say parallel because that's with lines, but they're like, the ground is always like basically level. Well, not always level, but for the most part level. The exception of like mountains and other stuff, but for the most part, on average as a whole, the ground's not like completely lopsided, 45-degree angle at one part of the planet. So the Earth's 100% round. It's 100% a sphere. There is no other arguments. So please understand that this is the only answer. 2 plus 2 is 4. The Earth is a sphere. Boom. Now everyone go home. Peace out. Gravity with the flat Earth is apparently this actually literally moving up at like, 9.8 meters a second upwards, so that, like, here, I'm gonna put it down here for now to really show you. So their apparent, like, theory for the gravity, or how gravity would work on if the Earth is flat or whatever, is that it would just move up at 9.8 meters a second, thus giving us, obviously, 1g. But see, this completely defies the basic laws of physics. Newton's laws of motion, maybe? Objects in motion stay in motion. A couple other ones. Just pull them up right now. Laws of motion. Okay, because this is not a theory. This is a scientific law. So if I can find the first thing. The object is constant. Here we go. Then the velocity of the object is constant. Velocity is a vector quantity which expresses both the object's speed and the direction of its motion. Therefore, as soon as you touch, you can read, hopefully. An object that is at rest will stay at rest unless a force acts upon it. An object that is in motion will not change its velocity unless a force acts upon it. So here's the thing. With something... First of all, let me make sure there's not another thing that I'm missing. I don't have enough time. I don't think I have enough time to go through all this. Okay, so anyway, what this means, essentially, to summarize it, is if you're a person, we're gonna make another we gotta make another parcheman. Just real quick. Real quack. Wait, oof, almost forgot the arms. Gotta make the arms. You have to make the arms, or else it is not an accurate model. Okay, so here's the thing. If this is moving up 9.8 meters a second, hopefully you guys can see this, then if you're standing on this, sorry, it's just kind of taking a while. Oops, I didn't mean to actually press lock. Oh, come on. You know I didn't mean to do that. I meant to press group. There we go. Then Bobby Boy over here, because that's the name of the guy, would also be moving at 9.8 meters a second, because he is also, let's move this to the front layer, he is standing on the Earth, so he would also be moving at 9.8 meters a second, and objects in motion stay in motion. So, just like when you're in a car, if you're in a car, pretend this block is a car. I'm not gonna spend like all day trying to frickin' like draw everything. You can visualize it. Let's say this is a car, and you accelerate. You accelerate to the right 60 miles per hour, or up to 60 miles per hour. Actually, to make it even easier for you. All right, here, I'll say 100 kilometers per hour. Okay, let's say this is a car, and you're going to accelerate up to 100 kilometers per hour. The only force you would feel would be the acceleration. Once you get up to 100 kilometers per hour, you wouldn't really feel anything. You wouldn't feel like your face is getting smushed into the seat, or your whole body, you know, because once it reaches the speed, you stay at that speed. This is also why, pretend this was a pickup truck. Here, we gotta make another Bob. Command C, Command V. Okay, so let's say this is now a pickup truck, and or a van or whatever, and you're on it, and it's going 100 kilometers per hour. Somehow you're still staying on that thing. I'm sure the wind resistance you probably wouldn't be able to stand on it, but just as a theory, or, you know, just pretend that you could, and you throw a ball 5 miles per hour off the thing. Doesn't really matter how big it is, technically. And you throw this 5 miles per hour forward. Is the ball only going to be traveling 5 kilometers per hour? As soon as it leaves your hand, is it going to fly back at your face at 95 kilometers per hour? because this thing's only moving at 5 and you're moving at 100. Like, no, this is gonna move at actually it is not 105. It is 104.999999999999999 because they've actually counted in the fact that the Earth is round. So actually, again, it's already been proven with that too. So why are we still on the subject? So once this would start moving at 9.8 meters a second, little Bob over here wouldn't be experiencing any more G-force, keeping him on the disc. Which means that he would probably be experiencing 0 G's, his feet, he'd probably feel like he weighs nothing. And then if little Bob were to jump, he would then be accelerating, like even if he just jumps, let's say like a meter per second, I don't even know if that's exactly 100% possible, but let's just say he jumps a meter a second. He would then be traveling 10 meters a second. Well, yeah, actually, yeah, that would still add up, right? That because it's not counting for the fact. Yeah, so you'd be traveling at basically 10 meters a second. But the only thing slowing him down would be air resistance. Air resistance. For a second, I couldn't spell. But as you can tell when you go outside, wind is not rushing down. So, I mean, obviously the Earth moves in space. Like, I want to make sure that you guys know what I mean when I said that. Like, obviously the Earth is moving in space, and it is moving pretty fast. And obviously the wind is not rushing that far. So, basically my point is if this was true, the fact that wind resistance really is not that much, he would still probably be able to fly up and away. Like, so that theory really cannot exist. There is no way the Earth's gravity is only caused by it moving 9.8 meters a second upward, because then this would completely defy everything else we know about our planet orbiting the sun and the moon orbiting us. You know, because then both those planets, the Earth, we would be experiencing so much G-force now because we're probably traveling a lot more than 9.8 meters a second around the sun. I'm sure it's an insane number. I don't actually know it off the top of my head. So we would be like, if this was Bob here and this was the Earth, we would be like, whoosh, like you wouldn't even know what just happened. That probably is to scale too if that was a real person, but the planet of course would have to be probably still a lot bigger than that, but that would probably be around to scale if this was actually moving, how fast the Earth moves. And we know the Earth moves through constellations in the sky, so unless you want me like and looking at them in between seasons, like when it's winter and summer, because obviously when it's summer you're on one side of the solar system and when it's winter you're on the other. So unless you want to tell me that the entire sky is a TV screen or something, and they just frickin' play what looks like a night sky in the sky, or some like false thing, and you want to tell me that they've been doing that since like the dawn of time somehow, like, I didn't find, and I guess there's no arguing with you. You're gonna continue to not look at the facts, and there is gonna be no way for me to really, I guess, get you to look at it otherwise. So, the fact that liquids fill their containers, and we definitely know there's a horizon, and that the ocean is indeed round. That and because also, even with every flat Earth picture I've seen, the oceans are all still connected, which means if they're all still connected, and the oceans are indeed curved in real life, then it has to be curved at the same rate, which then means, by far, the Earth is definitely a sphere. Now, technically, there could be a way I could somewhat technically calculate how long it is, somewhat. Not right now, because I don't have any actual, like, pictures in which I measured the distance of something, and then went back so much, and then measured how many, like, angles below. Like, technically, though, I could. But it doesn't matter, because we all know since liquids fill their containers and the ocean is round, we definitely know that the Earth definitely has to be a somewhat almost like perfect sphere, especially considering that the ocean is 3/4 the entire planet. So the Earth definitely has to be at least a somewhat perfect sphere. I mean, of course, mountains and valleys and different parts of the globe are gonna technically keep it from being a perfect sphere, but this has to prove that the Earth is indeed a sphere. Because if not, the ocean would not curve. The ocean would not curve at all. It would be flat. So please stop with this nonsense about the Earth being flat. Okay, that would be wonderful. Thank you, please. I hope you learned something today. I hope that it was that the Earth is round. Good day to you, sir, madam. I'm going home. Oh wait, I already am home. Screw you guys, I'm going home. This is Bob. He's looking around. He can't figure out how the frick no one can believe that the Earth isn't round or something. Like, he can't believe that people actually believe that the Earth is flat when it's clearly round. Because this is Bob. Look at Bob. You're not looking at Bob enough. Bob is extremely sad. Bob is frick. Bob is extremely sad. This is his face. This is Bob, alright? Bob is looking at you with those puppy eyes. Again. And they're blue because he's sad. And he's trying to understand. He's trying to understand how anyone could possibly believe anything different than what's right there in front of his face. And that is that... Why can't I rotate it at different angles? Oh no, I glitched it out. Oh no, Bob just died. Oh, because I had to prove this theory right. He just drowned in the middle of the ocean. Look, it's engulfing him. He doesn't know what he's doing. He dead. He dead now at the bottom of the ocean. This is a shark. He just ate him. Nom 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 nom. Now he dead. See guys, way to go. If you guys would have just believed that the Earth was round, Bob wouldn't have died. Frickin' gotta be kidding me. OMG. I don't even know what to save it as. Who the frick cares? We're done.